Madam, can I ask
Yes, sure.
from the question before?
Okay, yeah, sure.
Uh,
This question?
yeah. The b square equals to w square.
Okay.
Is that a formula?
Yes, it's a formula for law of cosine. It's a formula of law of cosine where you have law of cosine. Basically, you have a triangle where you have ABC. All right, you have ABC, and then this is small a, small b, and small c. So you have something like that. Okay, so you have like if you want to find the b squared is a squared plus c squared minus 2ac cosine b. This is one formula. If you want to find a, all right, so a squared equals b squared plus c squared minus 2 bc cosine a. Basically, if you look at the formula, it is regarding this oblique triangle. Okay, it is regarding this oblique triangle. So this, if let's say you want to find b, you want to find this, all right, it will be the length here squared plus this length here squared minus 2 times a times c and then cosine b. The angle is actually what we call the included angle. All right, so this is actually is the law of cosine. So if you refer to the slide, okay, you have the previous slide. Okay, you have actually this that. Okay, this is actually is the law. Okay, it's just that now our, if I'm referring to our triangle just now, I'm using a different letter like W, the B. Okay, but basically it's the same thing. Okay,
Okay, madam. Thank you.
all right. Okay, all right. Okay, any more question before we start with the new chapter? Any more question? All right, if not, then perhaps we move on to the next chapter. This is our chapter 4, which is about complex number. All right. Okay, for chapter 4 or complex numbers, okay, I hope also that this is not something new. Perhaps you also have done this before, you have looked at this before, or you have encountered this before. So hopefully that this is also a refresher course, all right, to you. But if it is like your first time, okay, learning about complex number, so please really pay attention. And if you do not understand, okay, you please ask, just interrupt. Okay, let's look at the objectives as well as what are the contents for this chapter. All right, so basically for this chapter, at the end of this session, or at the end of the chapter, all right, we hope that you are able to express what we call complex numbers in polar form, all right, and also in exponential form. Okay, beside the rectangular form, all right, so you also have polar form later on as well as exponential form. And then you are able to find what we call products and quotient of complex form in polar form. Okay, complex numbers in polar form, as well as using this theorem, what we call the De Moivre's theorem, all right, to find complex number with powers. Okay, and there are about like 6 sections, all right, or 6 subtopics for this chapter. So this chapter is actually is also quite big, all right, in the sense that there are so many stuffs, all right, happening in this chapter, all right. That you have what we call complex number and the properties, all right, which we are going to introduce you today, as well as polar coordinates, and then you have polar form of a complex numbers, exponential form of a complex number, or Euler's formula we call it, product and quotient of complex numbers, two complex numbers, as well as the last one is where using the De Moivre's theorem to find powers, okay, for powers or exponent for complex number. Okay, now the word itself is actually complex, okay, so complex, so it's like it's quite difficult, okay, it's complex, all right, so something which is not like usual, Okay, it's not like usual. Okay, so our usual numbers maybe like this. Okay, like this number, this all these numerals. All right, so you have your this is all what we call real numbers, right? 1, 2, 3, -1, all these are what we call real numbers. Basically, real numbers, all right, if you remember, real numbers are numbers on your x-axis. So if you look at, if you refer to your x-axis, okay, numbers on the x-axis, all right, numbers on the x-axis going from -infinity to +infinity, all right, these are what we call real numbers. Okay, these are what we call real numbers. Okay, from -infinity to +infinity, these are what we call real numbers. So any numbers on your x-axis from -infinity to +infinity are real numbers. Okay, so why there's such complex numbers? All right, why do you need to learn about complex numbers? Okay, this actually complex number came along when people would like to try to solve certain equation, especially quadratic equation, all right, in which the solution, okay, the solution for quadratic equation involved with square root of a negative number. Okay, for example, a simple example, right, you have such equation, x squared equals to -1. Okay, x squared equals to -1. So which means that if you want to find the x, we are going to take a square root on the right hand side. So what you have is actually on the right hand side is a square root of minus number or -1 in this case. Okay, so this is actually is the basis, all right, the basis of where mathematician, all right, they invented this complex number, all right, to take care of such equation. Okay, to take care of this type of equation, because previously if you remember, when you learn about quadratic equation, all right, when you solve for quadratic equation previously, when it comes to this type of solution, then last time we would say, okay, if we have something like square root of a negative number, then we will say, okay, therefore no real solution. We will say like that. Alright, either you say undefined, so you cannot compute, alright, or you can say no real solution, because there is no numbers in which you square you get -1. Okay, this statement x squared equals to -1 means that you have one number where you square you got -1. Definitely there's no such number, because if you put this x as a positive value, you square it, you got positive number. If you take a negative number as the x, you square it, it becomes also positive. So in this case, there's no such number in which you square, you get -1. So however, alright, when you have such equation, so when you want to solve previously, this is where we will say no real solution. Okay, so what mathematician did, alright, long time ago perhaps, they invented that, okay, this is what we call a complex number, alright, to take care of this type of equation. Okay, so that means, alright, after this, alright, when you encounter any such equation where you have a square root of a negative number, so that means there is now a solution, but of course, it is not a real solution, but in this case, we say it's a complex. It will be what we call a complex solution, okay? Because it becomes what we call later on a complex number. Okay, so then what actually this mathematician came up with, all right, they invented, all right, that this x equals to -1. Okay, it is actually, okay, from here, all right, that x equal to square root of -1, and this one they call it as imaginary, okay, imaginary unit, or they would say imaginary number. Okay, and they introduce, all right, that square root, all right, of -1. Okay, they introduce square root of -1 with a letter, all right, in mathematics, all right, we use a letter I. We use a letter I. But I think in engineering, because complex number has many application in engineering field. So maybe engineering, they use J. They use the letter J. Okay, they use the letter J. Okay, engineering, maybe they use the letter J, which represent as the square root of -1. Okay, so whether you encounter in your, maybe in your engineering classes, all right, complex number with the J, all right, don't get confused. All right, it's just a letter, but the rest of are the same. Look at in terms of properties, in terms of what we call the arithmetic operation and so on. So the rest will actually are the same, except for only the representation in terms of letters. Okay. All right. So with this complex number, or with this what they call imaginary number, then it completes actually a number system. If you remember, number system. Okay, number system. When I say of remember, number system starts from last time, maybe you learn about real numbers. Okay, you learn about real number as the, or as the top in the list of what we call number system. Okay, real number is actually at the top of the number system. Previously, maybe you learned this. Of real numbers, just now I mentioned, is all numbers from minus infinity to positive infinity. These are what we call real numbers. And then a subset of a real number is where you have what we call last time rational numbers. Okay, rational numbers as well as irrational numbers. Okay, if you remember irrational numbers. So what the difference between rational number and irrational numbers previously, if you recall? Rational number, example of rational number is you have something like a quotient form, a numerator and denominator. Like for example, 1/2. This is actually example of rational number. Characteristic of rational number, use calculator, you will get just 0.5. That's it. Okay. Or another characteristic of rational number, all right, maybe you have something, this is what we call a terminating decimal. Okay, terminating decimal, that's what we call rational number. Example of irrational number is where you have something like pi. Pi is actually what we call irrational number. Or any square root number like square root 2 is a irrational number. Characteristic of irrational numbers is where you have, like they call it decimal number which it is not, is different. Like for example, pi is 3.142, okay, or square root of 2 also, like 1 point something, whatever, where the decimal number, all right, the number after the decimal, you will see the number, actually the digit actually different. It's not like 0.6666. This is what we call are the same. Okay, this one actually it goes to this type of rational number. Okay, this is only for your understanding, but what I'm trying to say here, previously you learned about number system, and then of course a subset of rational is integer, all right, and then a subset of integer is natural number, then you have a whole number. Okay, so with this complex number now, all right, when the mathematician they invent, and only they said that okay, complex number will be at the top, and that will actually complete the whole number system. So complex number, then it becomes here, it becomes at the top of the system of numbers. Okay, so then this complex number basically, all right, number. And we have what we call imaginary number. Okay, imaginary number. Okay, so basically your I is here. All right, your I or your square root of -1 is here. Is under the imaginary number. Okay, I is under the imaginary number. So any square root of negative number will belong under what we call imaginary number or imaginary unit, they call it. Okay, so you will have like square root of -1, or you may have square root of -4, or any negative number, square root of any negative number, that will belong under what we call imaginary number. So then this complex number, they mentioned that it actually completes what we call the whole number system. in mathematics. So complex number consists of what we call the real number as well as imaginary number. Okay, and back to this, all right. Okay, so basically, okay, this is actually I. Okay, they introduce I, the letter I. Okay, they introduce the letter I as square root of -1, square root of -1. So when we square both sides, then that's when we have I squared equals -1. So if I equals square root of -1, then I square equals 1 minus 1. Okay, so this is logic, because when you square both sides, okay, you square both sides. So if you have your I equals square root of -1. So when you square both sides, okay, so that's when you get your I squared equals to -1. So this is logic. And in fact, this is what you also need to remember by heart also, that I equals to square root of -1. So then I square equals to -1. Okay. All right. And then there's a definition here. Perhaps we can go through here, which says that complex numbers are numbers of the standard form of A plus BI. Okay. The word is standard form. Okay, the word is standard form. So that means that is the way we write complex number in standard form. It is in the form of A plus BI, where A and B are real numbers. Okay, A and B are real numbers. A and B are real numbers. The real number A is called the real part. The real number B is called the imaginary part of the complex number A plus BI. So if A equals 0 and B not equal 0, then complex number BI is called a pure imaginary number. Okay, what does it mean from this definition? Okay, so it goes back to this number system just now. We said that complex number consists of real number and imaginary number. Okay, so then this is our standard form. So standard form is in the form of A plus BI. Okay, so that means, it means like this. All right, complex number, example. All right, this is like this. Or you may have like this. Or you may have like this. All right, in which what it means, all right, by the definition, standard form of a complex number is written as in the form of A plus BI, where A and B, this is actually is a real number, all right, these are real numbers, and this is also can be called as real part. This is imaginary part, all right, okay. And if A, just now we mentioned that if A equals 0 and B not equal 0, that means you have just this BI like that. Imaginary part. Pure imaginary part means there's no real part. Okay? When you don't have this real part here, only this BI. Okay, only this BI. So BI is just called as pure imaginary part. This is just a terminology.
Madam, you are mute. No, your WebEx is mute.